Apologies. So, without any further ado, I'd like to introduce you to Dave. And Dave is going to teach us all about mobile app dev. I love mobile app dev, so I'm really looking forward to Dave's talk. And without any further ado, here's Dave.
Thank you. So I'm here today to talk to you about mobile app development, specifically cross-platform development, what that is and why it can be useful. Quick bit of housekeeping, I won't be taking any questions due to the length of the talk, but feel free to approach either myself or any of my Adapter colleagues who are all milling about at the front here, and we can answer any questions later on. I'd like to take a quick chance to thank our sponsors. Without their support, we wouldn't all be here today. So I'd like to ask you, the audience, a few quick questions before we start. Could you raise your hands in the air if you've got a mobile phone? Anybody not got their hand up? Could you keep your hands up if you've ever used an application on that phone? Everyone? Keep your hands up still. Last one. If you've ever downloaded an app from an app store. I think that's pretty much everyone. Apps are part of everyday life now, whether it's photo editing, watching movies, reading comic books, house hunting, VR, or Angry Birds. We all use them pretty much every single day. They've also become vital to many businesses. Unfortunately, they can be expensive in terms of cost and time. That's where cross-platform technology can come in. So I'm going to try and answer these three questions today. What is cross-platform development? Is it useful? And which solution is for me? But before I do that, I'm going to take a short trip back in time. Prior to 2007, smartphones looked like this. Not very pretty. They had hardware keyboards, some used styluses. A few had touch screens, but they were slow and unresponsive. The SDKs weren't open. You couldn't get your apps onto these phones, and there wasn't anything even approaching an app store. And then, January 2007, this happened. Steve Jobs walked on stage and announced the iPhone. With its shiny, shiny case, its responsive, clear, colourful display, and its clever marketing, the iPhone caught the imagination of both the public and developers. Sadly for developers, at this point in time, there was no SDK for this phone. You couldn't get your apps onto it. At this point, the only apps you had on it were the basic ones: Safari, email, contacts. Pretty boring stuff. Apple had a trick up their sleeves, though. They were already using their own language, Objective-C, to build applications for their Mac platform. And they had their own IDE to develop this, Xcode. In March 2008, they released Xcode with the iOS SDK built in. Suddenly, you could start making apps for this amazing new device. At the same time, they launched the App Store, the first of its kind. This allowed you to deploy your apps worldwide with minimal effort. By the close of 2009, there were already 50,000 applications in the App Store. Today, there are more than 2.2 million iOS applications. Late 2008, these guys came along. Google released Android, which is based on the portable Java language. At the same time, they released their own Play Store, very similar to the App Store. 2.6 million Android apps at the moment. There were others such as BlackBerry and the ill-fated Windows Phone, but they were crushed under the might of Apple and Google. And these two have been battling it out ever since. Moving forward, in 2014, Apple released Swift. This was designed to be a cleaner, quicker, more modern programming language. It was backwards compatible with Objective-C, and at the same time, they released Playgrounds, which allowed you to do quick prototype development with Swift. Android still uses Java to this day. However, a lot of people have started moving towards Kotlin. Kotlin was developed by the company JetBrains, and this was designed to be a modern alternative to Java with features such as null safety, better generics, and data classes. So this got us to where we are today. Two platforms, both completely different. Clients often ask us for a price for one platform. They then ask us for the price for the second one, and we say, it's the same as the first one. And they get sad faces. The reason for this is there's no sharing between these platforms. Completely different languages, completely different development platforms, and two means of laying out the UX. That's before we actually get into the platform-specific differences, such as differences in navigation, how they treat push notifications, sensors, screen resolutions, the list goes on. Companies were forced to hire 2 different teams to develop their apps, or try and find the mythical creature of the dev who's good at both. They started looking ways to cut this cost, and devs started looking for shortcuts. One of the first solutions to this was Apache Cordova, previously known as PhoneGap. This is based upon web technologies such as HTML5, CSS, and JavaScript, familiar to anybody who's built a website. This allows you to run on pretty much any device that's got a web browser. It has web to native layer, which allows you to access things such as the accelerometer, the camera, and local storage. Later on, other platforms were built on top of this, such as Ionic, which gave you access to Angular, and React, again, very familiar to anybody who's done web development. This makes this platform really good for teams that have already web development capabilities. Because you're building a browser, you can use hot reloading, you can make changes to your application, reload it, and instantly see your changes. The downside of that is that if you're running a browser, you can't access the device hardware. You have to run it on the actual device to get that. Your performance isn't ever going to be as good as it is in pure native because it's a web page. It also doesn't look and feel the same as a natively rendered application. Plus side of that, your app will look exactly the same on both platforms. That can be good if you get a highly stylized app. If you want a native look and feel, that's not so good. At Adapter, we use what we call parser solutions. These are a set of tools that we use to do some of the heavy lifting up front. Swagger is a format that allows server developers to define the shape of their API and how to communicate with that API. Swagger CodeGen is an extension program for that, which allows you to take that definition and render it into a variety of languages, including Java, which is what we use it for. This gives us our Android model and how to communicate with the API. We then take that and we translate it with J to Objective-C. This takes Java code in, spits out Objective-C code at the other end. We have both our platforms. We also use SquidDB, which is a create, read, update, delete database. It's a SQLite wrapper built by Yahoo. The combination of these 3 allows us to connect to a web API, download the data, perform business logic on it, and store it in a database, and the reverse process, all cross-platform in a nice, clean way. We still have to build our UI, and we still have to do some of the business logic on the native side, but it does a lot of the hard work for us. One of the most popular frameworks at the moment is React Native. It's a JavaScript framework based on the popular React platform. This was created by Facebook, who previously been entirely web-focused, and this was their attempt to catch up with the native world. Powers apps such as Skype, Instagram, and Uber Eats. React Native differs from Cordova-style apps that instead of rendering to a web view, it uses the native APIs to render truly native front ends. Let's take a look at how it does that. I'm not sure how clear this will be from the back, but it doesn't matter. React runs JavaScript in the background thread to create a DOM. Differences in this DOM are pushed up to the React Native bridge. This all happens in C++, so it's fast and efficient. At the other side of the bridge, this is passed on to the native layers. So in Objective-C, this is in C, and in Java, we use the JDIs to connect. This allows us to have native performance and native controls. Other features, it uses the open source Yoga layout engine, which implements a flavor of Flexbox, which again will be familiar to a lot of people who have done web development. This is a lot simpler than either the iOS or Android layouts, a lot easier to use. Elements are defined with JSX, which allows us to implement your layout inside your code. The other major benefit is truly native controls. You render an alert. On Android, it will look like an Android one, and on iOS, it will look like an iOS one, because it is. Now, in order to demonstrate how much of a time-saving cross-platform development can be, I built an app. I built my cat fetcher, and those are my cats. So this demonstrates 4 parts of most modern apps. There's user interaction in the shape of a button. It connects to the internet and hits a web API, which the cats as a service part. This returns a random JSON file, which contains a URL to a cat image. We download that. We download the image and we display it. So first I wrote it in Swift, which looks a bit like this. 51 lines of code, plus a storyboard for the layout. Not an awful lot. Then on Android, 107 lines of code, plus the XML layout. Both of these probably could have been a bit shorter if we'd used certain libraries or whatever, but it was a quick example. So running, that looks like this. Android on the left, iOS on the right. I then built the same thing in React Native. That looks like this. Pretty much exactly the same. The big difference is when we look at the code. 52 lines of code. This includes the style, which is all seen in the bottom section of the render section. One code base, no duplication, a single language, JavaScript. You're not swapping between storyboards or using XML or any of that. Everything is in JavaScript. Over a 50% saving. Obviously, that's not going to be the case for every single application, but you're going to get some kind of saving in that, and you're not having to go back and redo the same stuff over and again. One of the new kids on the block is Flutter, and we had a really good talk about that earlier. This was developed by Google using their own Dart programming language. Dart was designed to be a simple, fast, predictable native language. Flutter's again slightly different in that it renders its own components to a canvas. This means it's very quick, and it's because it's doing its own drawing. It doesn't need the bridge that React Native uses. However, these widgets are its own design. They make them look like the native ones, but there's a risk they can fall behind. I saw an example just today where iOS 13 control has changed, and it doesn't look right in Flutter now. They're always going to be playing catch up. So again, it's possibly good for a highly stylized app, not necessarily great if you want pure native and you want cutting edge. Uses reactive programming as with React Native. It's got a quick entry. It's very easy to use and very good startup. It's a young community though, and the support for it possibly isn't as good as some of the other platforms. There's a lack of plugin support for it at the moment, but Google are really pushing this, and they're going to push it forward for their Android replacement, possibly. Last one, progressive web apps. There's claims that these are the best of the web and best of native apps. PWA is a website on steroids, or that's how it's been described. Works on every browser, every device. It's always up to date, and it's instantly available, the same as a native app. It's not a framework. It's a set of technologies that have been bundled together under this title. The main concern to be a PWA is that you pass Google's Lighthouse tests. This sets out a group of standards, such as being able to, it has to be an HTTPS, it has to be quick to download and respond, it has to be able to respond if you don't have JavaScript enabled. All of these concerns make it a PWA. It also has to be downloadable, which means it has a description that tells the browser how to download it, package it, and put it onto your device. This means they bypass the App Store. You simply go to the website and download it. PWAs are bound by what you can do on the web. So you can use push notifications, you can use Bluetooth, you can access GPS. You can't access certain other features such as contacts, NFC, and SMS. But this is changing all the time. Previously, you couldn't do payments, but that's coming very soon. Again, low data requirements. And one of the other things that's lacking at the moment is cross-platform logins. So you can't use things such as Twitter or Facebook logins. So, back to my original questions. What is cross-platform development? Cross-platform development is a set of tools or frameworks which reduce the overhead of writing for multiple platforms. Is it useful? Well, it can be if it delivers what you're looking for and provides a saving. If you don't get the performance, you don't get what you're looking for out of it, then it's probably not worth it. But for an awful lot of standard type apps, it probably is a good thing to do if you're going to deploy to both platforms. Which solution is for me? Well, we've gone through a bunch of them. If you want cutting edge and you want the best performance, pure native is still a great choice. Specifically, if you're trying to use newer technologies such as VR, wearables, the support just isn't quite there for some of the other platforms, and they're always going to be a step behind. parcel solutions I talked about. If you're already building native apps, then these can help you do some of the heavy lifting for you and leave you to concentrate on the front end. If you've got a web-based team already, then one of the web-based frameworks such as React Native or Cordova might be your answer. If you want a leading edge and you're looking to the future, then Flutter might be the choice, but you run those risks. There are others. Xamarin, which is great if you've got a C#.NET team. It's got great performance as well as it compiles down to native code. If you want a quick and easy solution and you've already got a website, then PWAs might be your answer, but that's never going to be a native app. It's never going to look like a native app. So the answer is really in figuring out what's important to you and matching with the solution that fits your specific use case. That's not to say that cross-platform development is always the answer. Give an example of where it can be difficult. We had a project where we had to render 2 maps on a single screen. It was working perfectly in iOS. On Android, the second screen wasn't rendering correctly. Either wouldn't appear or the map points wouldn't appear on it. We ended up having to delve down to the native code, tweak that, submit a pull request to React Native source code. If you don't have those skills, you wouldn't be able to do that. If you're relying on it as a web developer, as your solution to get on a native platform, then you can hit those kind of issues. As I mentioned, I won't be taking any questions. However, I will be putting this up as a blog post shortly on our website. And as I say, I'll be here for the rest of the day. And you can approach myself or any of my colleagues. Thank you.